Hello, everybody. Good evening. Is my screen visible? Please use the chat box as usual. Am I audible? And is the presentation visible now? Am I audible? We'll wait for another 2 minutes before we start. I see people joining. But please do let me know if you can get the audio as well as visuals of the slide. Can you see? Thank you, Rohini. Shall we start then? Okay. So, welcome you all to another week of live interaction session for the course Bioinformatics, Algorithms and Applications. So I'm Lavanya, PhD scholar at IIT Madras, who will help you through these sessions on Fridays between 6 and 8 p.m. Let's look into the topics for this week. The practice questions will be focused on construction of non-redundant databases, part 1 and 2, protein secondary structure and secondary structure prediction 1, 2, and 3. Okay. So let's start with question 1. Which of the following softwares is used for construction of non-redundant data sets? Option A, CD hit. Option B, blast clust. Option C, Pisces. And option D, all of the above. So Kiran, Hardi and Nagamani have said D. Any other answers? So we are starting with a very light question. Thank you, Ross. So we can all agree that all three softwares can be used for generating a non-redundant data set, right? So it is all of the above: CD hit, blast clust, and Pisces. Question 2. Sequence identities for sequences in pieces are determined by option A, structural alignment, B, blast, C, either A or B, and D, none of the above. So which of these methods or identities are used to create a non-redundant data set? Thank you, Devangana. Any other options? Okay. For those who are just settling in, we are at question 2. Sequence identities for sequences and places are determined by option A, structural alignment, B, blast, C, either A or B, and D, none of the above. Is a vague option. And we know that PISS uses both structural alignment and blast to get its sequence identity information. Therefore, it will be either A or B. Option C is right. Kiran, Nagamani, Devahana. Question 3. Prolin is favored in which type of turns? Is it type 1 turn, type 2 turn, type 3 turns, or none of the above? Okay. Nagamani, Devangana, Sandhya, and Ross all say the same answer. Anybody who's differing? So it's not none of the above, and not type 2 or 3. And in type 1, you have prolin in I plus 1th position, most often than not, right? So it's option A. Question 4. What is the span of rotation of dihedral angles? 0 to 90 degrees, option B 0 to minus 180, C 0 to plus 180, and D minus 180 to 180. Great. Good to see the response. So when you're talking about dihedral angles, we're looking into a 360-degree rotation, right? It can rotate about all the angles. Therefore, it has to cover 360 on the whole. Here you have just 90 and just 180 here, 180 on the other direction. But minus 180 to plus 180 covers the entire 360 degrees, right? And that's how your plots are also designed from 0 to 180 and minus. So option B is the right answer. The Euclidean distance between the sequences ADIKLAAILL and ADLKLAAIK using amino acid composition is. So I'll let you take 2 minutes to align these, derive the frequencies, calculate the distance. So I'm just making notes while you solve it on your own and drop in the answers. So please don't wait for me to finish writing. I'm just writing to while away the time while you work on it yourself, right? Sandhya says point 4. Agreements, disagreements. So I'm going to name this as 1. This is 2. Okay. So we're going to have the scores for 1 and 2 written here. So those who have completed Venkatesh and Sandhya, I would like you to watch if I'm making any mistakes because I'm doing it right now, not before. So A would be 1, 2, and 3. Devangana says point 2. Let's see which one's right. Point 3 for A, and D is 1, right? 1 I. So I finished 1, 6, and 7 in D. There are two I's, so point 2. Then one single K, so K would be point 1, and three L's, 1, 2, 3, point 3. All right. Now coming to the second sequence. We have A at 1, 2, 3, and 4. So we will try point 4 here. D at a single position, point 1. And then L, only one place. So L is point 1. K, two places. Oh, L is at two places. I made a mistake here. Thank you, Sandhya. L at two places and K in 2. I have crammed it up a little. I could have spread it up. And as long as you're able to see, it's fine. And then a single I. So let me quickly check if I have everything right. Point 0.3 plus 1, point 4. And you have 6 here. So that's 10. 5, 5, 10. Okay. K is point 1. Is it? I see two Ks here. And only one here. So point 1 for 1 and point 2 for 2. That was for Venkatesh. Any other answers? We have a point 2, point 4. So to start with, what is the formula for Euclidean distance? So we have been discussing two distances, right? One Hamming distance and one Euclidean. So you subtract the differences between the frequency of composition. So they sir had written the formula. I'm trying to follow the same. 1 of I minus composition of 2 I, and you're going to square it and summate all such. So you have one, two, three, four, 5 places only. So you're going to add all those and take a whole root of these. So what should I be doing? Whole root of first differences between point 0.3 and point 0.4 is point 0.1 square plus point 0.1 and point 0.2 there is nothing. Then there should be a square, right? For Euclidean. Only for Hammings you don't have a square. For Euclidean it's sum of squares and you take a root again. Right? For I, this is for A. This is for T. For I you have point 0.1 again square. Plus for K you have point 0.1 square. Plus for L you have point 0.1 square. So this is useless. It will be 0.01 into 4 times. 1, 2, 3, 4. Which is point 0.2. Who said it right? Devangana. Was that okay? I think Sandhya did not square. That's why you got 1.1 plus point 0.1 plus point 0.1 plus point 0.1, which would be right for Hamming's distance. Is this clear? Everybody agrees on point 2? Alright, moving on to question. Okay, so we got the answer. Question 6. CD hit stands for option A, cluster database for HIT molecules. Cluster database for high identity with tolerance, cluster data bank with high identity tRNA sequences, and D cluster database at high identity with topology. Thank you, Akriti. So in the first question, we saw that CD hit is a software or database used to generate non-redundant data sets. So you can easily, omit tRNA sequences, topology, where we are not worrying really about topology. Hit has not been expanded, and there is no molecules. We are not talking about hits here. So, right answer. I mean, I'm just eliminating the wrong ones, but truly, CD hit stands for Cluster Database at High Identity with Tolerance. Thank you all who answered this. Option B is right. Question 7. GOR method uses the information on option A 18 residues on both sides of the central residue. Option B 4 states of secondary structure. Option C window length of 17 residues and 4 states of secondary structure. And option B window length of 17 residues and 3 states of secondary structure. Divangana says A. Akriti says C. Nagamani feels A. Sandhya also says A. So we have more votes for A and one vote for C, two votes for C. Others? No takers for B and D. Okay, Nagamani has shifted sides. So the majority is C. So shall we go with C? What is the difference between A and C? 8 residues on either side of central residues still gives you 8 plus 8 plus 1, 17. Right? Sandhya has also shifted sides. So that's a clear majority, guys. So window length of 17 is true in 3 options. This is again a size of 17. And the only option that does not talk about the information on 4 states of secondary structures of who, right? So you can outright eliminate B. But without B, A is incomplete. C is just the combination of A and B put together. Window length of 17 residues and 4 states of secondary structures. And what are those? Whether it's a helix or a strand or a turn or a coil. So GOR method uses the information on when you look at the options, it will suddenly jump at you and say yes, this is the GOR method, but true, but just partial. You need to look into the There are options which are more specific with the four states of secondary structures, right? So the answer is C. I just pasted a short slide, but I think it's covered in the lecture as well, so don't worry about this. Question 8. Hydrophobicity profile method identifies the secondary structures based on option A patterns, option B amino acid frequencies, option C position conservation score, and option D all of the above. So I'm expecting different answers for this. Okay, Nagamani says B. Oh, so do Savinder, Hardi, and Akriti. We have four Ds. Others, Sandhya also says D. And fills up. Okay, guys, let me give you this. Think about option C. Have you ever worried about position conservation score in hydrophobicity profiles? Last week we did a extensive hydrophobicity profile. We built our own for one of the questions, right? Was position conservation score considered in hydrophobicity profile? Think about this and then rethink your option now. Do you still want to stick with D? I mean, if C is gone, so is D, right? Okay, Venkatesh says B, Samiksha says B, Elza says B, Kriti says B. Nice. So, given A and B, Mamata Shri says A. Nice. B has one, two, three, four, five votes, and just Mamta for A. Anybody else to give Mamta company? It's a very simple yet interesting question. So, amino acid frequency. What frequency are we talking here about? Is it their frequency of occurrence? Is it their frequency of taking up a particular secondary structure? It's a very vague term here when you say frequency. But I think most of you jumped at it because you were thinking about hydrophobicity scores, right? So when you were thinking about hydrophobicity profiles, you probably thought we'll have the sequence here and I'm going to assign the frequencies and then go about this. You are assigning numbers, but those are hydrophobicity indices or scores. Again, based on its frequency of being found in or being more hydrophobic or less hydrophobic. So it's a score essentially, not a frequency, but identifies the secondary structure based on when you're having a profile, something like this. You're identifying the secondary structures based on the frequency or based on patterns. It is the pattern that we are looking for. Excuse the call. I hope I'm audible again. So, correct. We use hydrophobicity indices, hydrophobicity scores. Sometimes we average it over a window length. Sometimes we take the absolute scores and plot it, right? But it is always the pattern that guides you in identifying secondary structure through hydrophobicity profile. And it is not the amino acid frequency or position conservation score, and definitely not all of the above. So I would go with patterns. And congrats to Mamta for the single vote on A. Question 9. If a protein consists a total of 1800 residues and 810 of them are helix, considering the residue alanine among 300 residues, considering the residue alanine among 300 residues, 240 are in helix. What is the information content of alanine in helix? So what is I? Take a minute. Okay, Kritika, we'll solve it now so you'll understand how it is done. Others, take a shot. So, one clue that I would leave with you is that alanine is, we know it likes to be a helix. So, your options should fall within here. If you get some value in this range, or you think A or B is the answer, reconsider, recalculate. But if you're finding something in C or D, you're probably in the right track. So, while you solve, thank you, Venkatesh. Anybody else? Nagamani says C, which is again 1.59, I think. Total is 1800. So, alanines are 300, of which 240 are helix and 60, right, are not helix. I'm just giving H and NH. Hardi also says C. And when you take all other residues in general, I'm going to give residues, which is again 1800. And how many of them are helix? 810 are in helix. 810. So that leaves us how many? 800,000 minus 10 would be 90, right? It is a 18. Okay. So 810 are helix, 990 are not helix. So, for people who are confused with this question, I is given by the ratio of ln of probability, or I think you can go with probability of SS. For simplicity, I'm going to go with ln of A in probability of alanine as helix divided by probability of alanine not in helix. So I'm using the same annotations here, minus ln of probability of all residues in helix divided by probability of, thank you Sandhya, R in H. Okay. Now, how do you find probability of AH would be 240 divided by 300. What is that? 8 3s are 24, 6 5s are 30, 6 4s are 24. Right? So that will be 4 by 5, which is zero point 0.8. Correct? So PAH is equal to zero point 0.8, and P of ANH, I'm just giving, instead of everything being SS and SS, not SS, I thought this will be easier for people to follow. So you need not follow the same naming, but just do the answers right. So this will be 1 by 5, which is zero point 0.2. Now, what is probability of all residues being helix? 810 by 1800. This is 0.45. And probability of residues not being helix is equal to 990 by 1800, which is going to be 1 minus 0.45, right? So this is 0.55. Now, going back to calculating, I is equal to ln of, what is PAH? zero point 0.8 divided by zero point 0.2 minus ln of 0.45 divided by 0.55. So this will be 4, right? Ln of 4 minus 0.45 by 0.55 is 0.8181. So this is giving me an answer of minus zero point 0.2, and ln 4 is 1.386. So I'm going to uh, round it off as 1.39. So 1.39 plus zero point 0.2 would be 1.59. Answer is C. Was that clear, Kritika? So you start by listing out what is the, yeah, total number of residues and how many of them are helix and not helix, and particular residue that is asked in the question, how many of them are in helix and not helix. Just make ratios, take logarithm log, and you'll be done. Okay. Question 10. The phi and psi torsion angles are rotations along dash and dash bonds respectively. Option A, C alpha C and N C alpha. B, N C alpha and C alpha C. C N C alpha and C N. C C alpha and C alpha. phi and psi. Okay. This is the peptide bond. We have another peptide bond here which are planar, right? So rotations are going to be there in these bonds. So NC alpha is one option, C alpha C is another option. So C and N is not an option. Eliminate this. C alpha is okay. Okay, NC alpha is okay. Oh, so many have answered. I just saw. Okay. So we're all clear, right? This is phi, this is psi. So N to C alpha is phi, which is not there in option A and D. And C alpha to C is phi. I'm sorry, psi. This is psi and this is phi. Option B is right. Okay, so we're going to do this week's assignment, which has already been finished and answers have been released. But if you have not already looked into it, don't. We'll discuss now. Question 11. If a protein contains a total of 1000 residues and 600 of them, now Kritika can do it yourself and post the answers in the chat. You're having 1000 residues, of which 600 are helix, 400 are not helix. Considering alanine, among 100 residues of alanine, 80 are helix, 20 are not helix. So I is equal to ln of 0.8 by zero point 0.2 minus ln of 0.6 by zero point 0.4 is equal to ln of 4 minus ln of 1.5. 4 was 1.39 minus ln of 1.5 is 0.4, which gives you 0.98. This was 0.386 before, I think. Yeah, if you go by that, you will get a nice 0.98 answer for this. It's not negative, not this, not this. The right answer is T. Thank you all for answering. Question 12. Protein secondary structures are formed by side chain hydrogen bonds, side chain hydrogen bonds, main chain hydrogen bonds, and all of the above. Nagamani, do you want to rethink the answer? Thank you, Filza, Akriti, Nagamani. Okay. Hardi, Venkatesh, Amtashri, Savinder, Samiksha. Great. So we all agree that it is between main chain and not side. Okay. Question 13. In the command blast clust I in file O out file BT L.8 BT and S85. Point 8 stands for thank you. Everybody agrees with Akriti, Filza, Venkatesh, Mantashri. Okay. So when we are talking about the length of coverage here, right? And not similarity, not identity. Actually, identity is the 85. So 80 is not for similarity or identity. Option C is the right answer. Question 14. Which of the following is true for an alpha helix? That it has a 3 residue per turn, or it has 5.4 residues per turn. Alpha helix has 1.5 angstrom rise per turn or 2.5 angstrom rise per turn. This is wrong. This is wrong. It's 310 helix. So what else have we got? 5.4 angstrom per turn and 3.6 residues per turn. So this is wrong. The only option that we have left and which is true is 1.5, which you get by dividing these. Right? Great. Question 15. What is the Hamming distance between the sequences ADIKLAAIKL and LKDAAIAIKL? Is it the same question? But that was Euclidean and this is Hamming's distance. Once again, okay, you're all saying C. So is that right? It's so great. One, two, three. So I'm just going to write those residues that matter. A, D, I, K, L. So this is point 0.3. D is 1. I is point 0.2. Assuming this is a 10 residue thing. Yeah, it's 10. So L is point 0.2 and K is point 0.2. So are we right? Yes, 1. And for second you have L point 2. 3 A's, so it is point 0.3. 2 K's, 1 D and 2 I's. 1 D. Okay. So these are absolutely the same, right? So there is zero distance between any of these residues. So correct. Everybody who answered C, thank you very much. Okay. What is the propensity of glycine to be in helix H for the following assignment? How do you calculate this? That's already Kritika will do now. Others? So I'm going to write this spread out again. because it's hard to see what is what, right? B, B. Okay. And how do you find propensity? It is the percentage of, maybe I'll change color because I don't know how well this blue is visible. Percentage of glycine as a helix and percentage of helix in all residues. A and C. So let's do the numerator first. So where all we have glycines, 2 here and 1 here. So out of 3 glycines, only 1 is in helix, right? So percentage will be 1 by 3 into 100. This is for just the numerator, divided by percentage of helix in all the residues. How many do you have? 1, 2, 3, 4, and 5. So I have 5 by 10 to 100, right? So this is 33% divided by 50%. Or you could just cancel out the hundreds and go with 0.33 by zero point 0.5. Both are the same, right? So this would leave you with half of 0.33. So now the money it's not 0.33, it is 0.66. Was that clear, Kritika? Not one one. When will you have
Yes,
one? Everything is helix, or they have the same frequencies. So let's say there are one third of this. If you had 3 by 10, only 3 of them were helix into 100, and on top you have 1 by 3 into, even this is not right. If you have something like 3 by 9, then you are looking at a situation where you will get 1 as the answer. Okay. Uh, on the right, I just have some information that I simply pasted from, I think, Wikipedia. This has no use here, but I thought it'll be a nice read in case you want to get deeper into DSSPs. Okay. Question 17. In Ramachandran plot, the allowed regions for left-handed helical conformation are restricted to quadrant. Okay, two people for A, which is first quadrant. And sometimes you might know the answer but are confused as to which quadrant it is in. Three boards. 4. I think so. Everybody agrees on A. It's not B, C, or D. So I have a picture here that says left-handed alpha helix right here. So it's in the first quadrant. It's given by option A. How many atoms at the minimum are required to compute torsional angles? Option A 2, B 3, C 4, and D 5. Thank you, Madhu. Thank you, Akriti, Nagamani, Mamta, Fiza, Savinder, and Pradeep. So you need at least 4 to compute torsional angles. Question 19. Which of the following statements is used to calculate the identity of protein sequences in CD HIT? So when we are talking about identity, it naturally eliminates A and B. So the number of identical residues divided by length of shorter or longer. This is where the difference comes. It is the shorter sequence, right? Because when you're comparing the identity of two sequences of varying lengths, if you have so many identical, you have to divide it by the length of the shorter and not the longer sequence, correct? So option C is the right answer. Blast clust is used to cluster only protein sequences, only nucleic acid sequences. Both protein and nucleic acid sequences cannot be used for protein or nucleic acid. The straight question, right? True, true, only is false. Therefore, both, and this is false. So, option C is right. Thank you all. So, I have another 2 or 3 MCQs. Secondary structure prediction using statistical analysis is proposed by. This is the first method. Thank you, Akriti and Mamtashri, Devangana, Hardi, Lisa, Nagamani. Okay, all of you are right. It's developed by, proposed by Chow Fasman. PhD in secondary structure prediction is based on neural network, multiple sequence alignment, and neural networks consensus. Thank you, Devangana and Nagamani. C is just A plus B, right? Consensus is a separate way of doing this. So PhD involves just multiple sequence alignment and neural networks. What is the Hamming distance between the sequence HLIKLAAIWL and HLWKLAIWE? Am I right? One, two, three. I'm missing something. Two L's, one K, one W, that gives point 0.4. Okay, what mistake am I making? 2, 3, 4, 5, 6, 7, 8, 9. 1. Oh, there are 3 L's. Oh my god. Okay. And here you have 1, 2 W's. Then, okay, so the differences are in these 4. So it will be zero point 0.1 plus zero point 0.1 plus zero point 0.1 plus zero point 0.1. Anybody else getting a different answer? Just for sequence 1 and sequence 2. So Devangana and I are going with D. If somebody thinks it's A, B, or C, now is the time to tell. Akriti also says D. Hitesh says D. Hardi, I'm sorry. So that's the answer. D. Question 24. Which of the following conditions best represent a set of non-redundant sequences? No two sequences have a similarity of less than 90%. No two sequences have a similarity of greater than 90%. No two sequences have a similarity of less than 30%. And no two sequences have a similarity of greater than 30%. So when no two sequences have a similarity of less than 90, which means they are 90% at least similar, right? And we are talking about non-redundant. So there goes option A. Option B, no two sequences have a similarity of greater than 90%. So at most it is 90% similar. Again, not a great non-redundant data set, so useless. So option C, no two sequences have a similarity of less than 30%. So again you have at least 30% similar, and no two sequences have a similarity of greater than 30. So best represent a set of non-redundant sequences would be D and not C. Good Akriti, your thought is right. So it is option D. So with this, my questions for the week are done. In case you want to drop in any comment or question, please feel free to do so. Anything? Sure. So let's do the propensity for Y. Okay? Because this will be very boring if I do the same thing, right? Let's go to presentation mode. Now, when you're calculating propensity of a particular amino acid, how you calculate is that what fraction, okay, of these residues, when I say tyrosines, as what is the propensity of tyrosine to be a helix? So number of tyrosines that are seen in helix conformation divided by number of tyrosines in total. This is for just the numerator. And for the denominator, you have number of residues in helix divided by total number of residues. So to make this a little more neat, I would go with propensity P is equal to number of amino acid in secondary structure divided by total number of that particular amino acids, whole divided by number of residues in that secondary structure divided by total number of residues. So here you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's do number of what is the propensity of tyrosine to be in beta strand. Okay, so would be what is the number of tyrosines in, okay, let's do glutamic acid then. Let's do glutamic acid. Okay, now I have spread this out so it is easier for us to see. How many glutamic acids do we have? One, two, three. Correct? So total number of amino acid E would be 3. And how many of them are in beta? Only one. The other two are in helix. So 1 beta strand by 3. This they're just multiplying by 100, but whether you do or not is immaterial because both are in percentage, it doesn't really matter. And on the denominator, you have number of residues in that secondary structure. What is that secondary structure here? Beta strand. How many are in beta? 1, 2, 3, 4, 5. So 5 divided by what is the total? 10 to 100. Oh, weirdly enough, this is also going to give us the same answer. 1 by 3 into 10 by 5, which is 10 by 15, which is 2 thirds, 0.66. Was that clear, Dilbamana? Or we could also do E as helix, which would be number of E is 3, helix is 2 by 3 all divided by 5 by 10. So what's the answer for this? 20 by 15, which is a positive value, right? 1.33, which holds true because there are so many E's in, so many 2 E's that are in helix. So you have a value greater than 1. Any other question in today's session that you want me to repeat? Okay, I'll give you another 1 or 2 minutes to think. Okay then. So in case if there is something, please do use the ask a question portal. So we'll meet again next week, Friday between 6 and 8 p.m. with week 6 questions. Alright then, thank you all for joining. See you later. Thank you, Nagamani. Thank you all. Thank you, Hardeep. Thank you, Savinder.